Hi there, it's Ralph. Let's make a 3D game in 1 hour. This video is for beginners who want to discover game development. It doesn't matter how old you are or if you never coded before, you will be able to follow along and have a working game at the end. We are going to use Unity to build our game. If you have not installed it yet, I have a video that explains exactly how to do that. The link is also in the description. Also, this video is split into chapters, so it's very easy for you to follow along, pause and rewatch. Alright, that's all for this introduction. If you're enjoying this, please leave a thumbs up and subscribe for more game dev. We are ready to create our first project. Let's open up Unity Hub, and at first you should see the project view. That's a place where all your projects are listed. To create a new project, click on New. There we can choose a template to help us get started. A template is just a help, it's very useful. For a 3D game, I like to take the universal render pipeline. It comes installed with a few packages to make our game look beautiful. Let's choose a name for our project, like Pong, and we choose a destination folder. I recommend you create a folder called Unity Games and inside a subfolder GameDev. That way you keep things well organized. Alright, click on Create and go grab a glass of milk. This might take a few seconds or a few minutes. And here we are in Unity. Welcome. Let's just take a look at what we have. The main area that catches our eye is the center area. This is the scene view, it's our game world. On the left, we have the hierarchy. This is the list of objects that exist in our scene. Just under this, we have the project panel. There you will see all the files and folders in this project. And on the right, we have the inspector. It will update and change based on what we have selected. After that, on the top, we have some tools. On the left, we have tools to move, rotate, scale, and so on. In the middle, there is a play button. And on the right, we have more tools and options that we don't really need right now. In Unity, everything is a panel. You can move them around and some panels have tabs as well. That's all for the little intro. In this particular course, we keep it short and simple. We just want to discover Unity and create a small game. Alright, the template we choose came with a demo scene and some assets. We don't need any of those, so we are going to clean up the project. In the project panel, select the README and delete it. Delete on Windows and Command Backspace on Mac. In the hierarchy, select the example assets and hit delete. Back in the project folder, see this example assets folder? Well, delete it as well. Then in scripts, delete what is inside. Then select the camera, look over to the inspector and scroll all the way down. There where it says script, click on the 3 dots and choose Remove Component. Finally, we can also remove the tutorial info folder. Perfect, now it's much cleaner and we can move on. Everyone loves Pong. It is the first computer game ever created, manufactured by Atari and released in 1972. This arcade game was a huge success. Before we start building our game, we will do a very small plan. Describe the gameplay and list all the features that we are going to have in our game. It's always a good idea to start with a plan. But first, let me show you the end result. Introducing Cyberpunk 3D. Inspired by the world's most popular game, you play as a massive racket with engines. You must face the evil and unforgiving purple racket on the other side of the field in a cyberpunk-inspired arena. Master the art of hitting the ball at the right place. Play forever against the computer or invite a friend and play against each other on the same keyboard. Alright, I'm having too much fun with this. That's the game that we are going to make. Let's now write a small plan and list all the features. What do we have? The game world is basically the arena and everything happens within that arena. We have 2 players and each player can only move on one axis, up or down the field. The player can play against the computer or against another human player on the same keyboard. When the player scores a goal, he gets 1 point and then the game resets. At the start of every game, a 3-second countdown is shown on screen. At the end of the countdown, the ball starts moving in a random direction. The ball direction can be affected based on where it hits the racket. Last feature. The first time the game launches, the player must press the space key to launch the countdown. Okay, that's already a good amount of work for us. Next, let's just very quickly talk about the art. I chose to go for a cyberpunk vibe. This means dark environment, it's night, it might rain a lot, and there are a lot of neon lights. The 3D models will be a bit more detailed than a low poly style, but not super detailed. The textures will be flat colors and certain areas will glow. For this discovery course, I've created all the art already and you will get everything to download. There is a player racket, the full arena and also a fancy ball. All models have been textured and the player is even animated. Great, we know what we want to build and we have a small plan. We also have the artistic style set and we have all the final models. Now there's only one thing to do, start working. For this course, we are not starting from nothing. I've prepared a few game assets already. You should have downloaded it already and just make sure you unzip it first. Inside, there are a few files. The one we want is the cyberpunk3d_assets.unity package. The best way to import it is to drag and drop it into Unity. The import window will open and this shows you all the things that will be imported. You will get some animations, a few materials, textures, some 3D models, and some prefabs that are ready to use game objects. Make sure everything stays checked and click on import. And that's how you import an external package. You can navigate in the project folder to confirm that you have imported everything and all the new assets. And now we are ready to set up the scene. Let's do some level building. Luckily for us, we have the final assets ready to use. In the art folder, there is a folder called models. And there you have the 3D models. Those are the raw 3D models. I've already prepared and set up the models so that we can focus on other things in this course. So just switch to the Cyberpunk 3D starter folder and drag and drop the arena object into the scene. There you go. In the inspector in the left, you see that our arena has a transform and the position is set to some values. Let's keep the arena at the origin of the scene. For that, you can change the values manually or click on the 3 dots and choose Reset. Before we move on, here are a few tips to navigate in the scene view. First, I really recommend that you use a mouse. Even on a laptop, the trackpad is not giving a super experience with Unity. Here's the basics with the mouse. You can use the scroll wheel to zoom in and out. Click on the scroll wheel to move left, right, up and down. Then you can right click and move to look around. And if you Alt and then left click, you will be in orbit mode. That's just a few tips. Eventually you will get used to it. Alright, next we will drag and drop the player from the same starter folder into the scene. Set the position to 0, 0, 0 and then with the move tool we can click on the red arrow which controls the x-axis and move it back. If you click on the green Y icon on the gizmo in the top right corner, you will change to top view and this might help place the player. I'll place it right in front of the red glowing line. After that, we will rotate the player. I will select the rotate tool with the shortcut E and click on and drag the blue circle. If you hold Ctrl or Command, it snaps at 15 degrees intervals. Let's rotate -90 degrees. And if we don't have exactly -90, we can set the value in the inspector. I'll also put -13 on the X position to have a nice round number. Let's move on to the ball. I will show you how to handle a raw 3D model. From the Cyberpunk 3D starter folder, drag the gray ball into the scene. Then reset the position to 0, 0, 0 again. In the same folder, there is already a material called ball. If you select it, you will see that there is a base map for the texture and there is an emission map for the fancy glowing parts. You can drag and drop the material on the ball in the scene. And there you go, gorgeous. Next up, what about the camera? If you zoom a bit out and select the camera, a preview will appear on the bottom right corner. You can also switch to the game view, which is next to the scene tab, and see what the camera sees. One thing to know about the game view, it is that it's not the scene view, obviously. You can't interact with any object. Okay, let's change the camera transform. We want to put it at the top of everything and make it look straight down. If you put the cursor on the position X, the cursor changes, and if you click and drag, you can change the value like a slider. So for X we want 0. For Y, I will put a value of about 20 and Z also at 0. The rotation. X does this, and this means we want 90 degrees, and the rest is set as 0. The camera work is done. I will switch back to the scene view. The last thing we will do is organize the hierarchy. I will right click and choose Create Empty. This creates a new empty game object. I will name it Gameplay. reset the transform, and then I will simply drag the player, the ball, and the arena into the gameplay object. This is really optional, but it keeps things clean and organized, and if I want, I can move all together. Over time, with more complex games, you can easily be at hundreds or thousands of game objects. That's where the hierarchical organization becomes very useful. So, better start with some good habits now. At this point, the scene is pretty good. Let's move on. You might have noticed that the colors are pretty faded and washed out. The reason for that is the fog. The universal render pipeline by default has fog turned on, and in most cases it's something that you want to make your environment more realistic. Fog works based on the distance of the camera to the objects you are looking at. Since our camera is 20 units away, it's pretty far. If I change the white position on the camera, you see that the fog effect changes. Let's fix the fog for this game. At the top, click on Window, Rendering, Lighting. A new window will open, and what is important for us is a second tab called Environment. At the bottom, you see the fog settings. You can turn it off or on, change the color, the computational method, and the density. I will change the density first, and I like a value of around 0.015 for this style. And I'll also change the color to add a little bit of a blue tint. And that's it, it looks much better. The colors are much more vibrant, a true cyberpunk arena. Here we are, our first script has been created. Before we start writing code, we can put the script on our racket. We do that by making sure that the player is selected, and then drag and drop the script into the inspector. Let's now double click on the racket controller script and open it. This is our basic script. At the top, we import some modules. Then comes the class definition. This is where our racket controller starts. It inherits from MonoBehavior, which is the basic class for any Unity script. It has lots of variables and methods like start and update that are called during the life cycle of the object. Now, what do we want to do? We want to make the player move at a certain speed, and we want to react to two keys so that we can move up and down. Let's create some variables. I will write public float speed and semicolon at the end. Then public key code up and public key code down. Every line of code finishes with a semicolon. Public is all lowercase and key code is with an uppercase K and C. Save with Ctrl or Command S and go back into Unity. Now with the player selected, you should see that the script component changed and we have some new fields. They have appeared because we said that they are public. Now in the speed, how about we start with a value of 6.5. Now we can define two keys. And since I have a QWERTY keyboard, I will choose W for up and S for down. Okay, the variables are set. Still, if you play, nothing will happen. So this is our to-do list to make it work. We need a reference of the rigid body. We need to detect the player input. If the player presses up, we move up. If the player presses down, we move down. And if the player presses nothing anymore, we stop all movement. Okay, let's get the rigid body. I will add a private rigid body called RB. Don't forget the semicolon. This is just a variable. There is nothing in yet. We need to go get the rigid body ourselves. In the start method, we say RB equals get component, and between the comparison signs, we write rigid body, parenthesis at the end, and a semicolon. Get component will get the rigid body from the game object where the script lives on. It's our player. We do it like that because get component is very expensive. So we do it once at the start and store it in a variable. Now let's take care of the player input. The update method is called every frame. So for example, 30 times per second if your game runs at 30 frames per second. Let's write bool pressed up equals input.getKey and in parentheses this.up. Bool stores a true or false value, so yes or no. Input.getKey is a Unity method that will return true if a particular key is pressed and false otherwise. The method wants a key code, so we give it the up variable. I wrote this up to show it exists as well. This refers to this script. Alright, let's do the same but for the down key. Bool press down equals input.getKey, parenthesis, this.down. Okay, now we want to move up and down. If we take a look in Unity, we see that we want to move along the z-axis. This means if parenthesis pressed up is true, curly braces, if it's true, we will set the velocity to move in positive z direction. rb.velocity equals, and we need to do some vector math, so vector3.forward times speed. In Unity, forward means positive on the z-axis. Now for moving back, if pressed down, then rb.velocity equals vector back times speed. And finally, the last case, if nothing is pressed, which means not pressed up and not pressed down. We will set the velocity to vector3.0. For the short explanation, the logical not is an exclamation mark and the logical and is a double ampersand. Now, side note, you can make this code shorter, for sure. This is one way to do it that is clear and easy to understand no matter your level of coding. Alright, now, very important, save the script and then go back to Unity. Unity will recompile quickly and you can click on the play button located at the top. And if you press the keys that you have defined, so for me it is W and S, the racket will move. Amazing. Oh, but we moved out of the arena. Our collisions don't work as expected. That's because colliders have to collide with other colliders. We need to put colliders on other objects as well. That will be the next step. We have a small problem. When we play, the racket can move into the walls and out of the arena. Obviously, we don't want any of that here. Our player has a collider, but that is not enough. The arena needs one or more colliders as well. We could add a mesh collider on the arena, and this would fit the arena perfectly, but we don't need that level of detail in our game. Our game is so simple, we can use box colliders to define the limits. Box colliders are also very efficient and will make any collision computation super quick. Always favors simple colliders over mesh colliders. For this course, half of the work is already done. If you select the arena object in the hierarchy and open it up by clicking on the small arrow, you will see that there are a few child objects. One of them is called walls, and if you open that one up, you will see a top and bottom object. Those are simply empty game objects. They are placed at the right location, and the last step is to just add a collider to them. Go ahead and select one of them, and in the inspector, click Add Component and look for Box Collider. Let's now edit the collider and use the handles to make it cover the wall length. We also make sure that it is close to the wall. Alright, I'm happy with the result. Now, instead of redoing all the work again, I will click on those three dots next to the box collider and choose Copy Component. Now select the other wall, for me it's a top wall, and click again on the three dots, and this time choose Paste Component as New. That's all for the walls. Let's hit play and confirm that the player can't get out anymore. Alright, it works. Exit play mode and let's move on. In this video, we are going to make the ball move by itself. We are going to use physics for collisions, but I will demonstrate another technique to make game objects move. Instead of using constraints or velocities, we are going to set the ball as kinematic and manually move it. At this point, you should be comfy adding components. Let's select the ball in the scene and add a rigid body. The rigid body is kinematic, so we tick the option. Then we need a collider, and this time we will take a sphere collider. Now make sure to check Is Trigger. Our sphere collider perfectly fits the ball because there is a mesh component on our object. It allows the collider to use the same dimensions automatically. Now we are all set, we can start coding. In the script folder, right-click and create a new C# script. We will call it ball controller. With the ball selected, we can already drag and drop the script into the inspector. The beginning of the script will be similar to the player one. We will need to store the speed, have a reference to the rigid body, and we are also going to store the initial direction. So public float speed, private vector3 direction, and finally private rigid body RB. In the start method, we call getComponentRigidBody, and we store it in this.rb. Then we initialize the direction to a new vector3. I will set x and z to 0.5 and keep y at 0. In C# we have to put the letter F at the end to make sure that the number is of type float. This references this script, so the ball controller. We can also remove this keyword because the names are unique in this case. Next up, I'm going to demonstrate two ways to move a kinematic rigid body. The first method is straightforward and modifies the transform of the object. This means that we actually don't use a rigid body at all. In this case, the rigid body will only be used for the collision detection. In the update method, we write transform.position plus equals direction times speed times time.delta time. This is simple vector math. What is special is time.delta time. This allows the code to be frame independent. If we don't do that, fast computers running at 60 frames per second would see the ball move much faster than slower computers running at 30 frames per second. And that's all. This is for the first method. It's pretty easy. Let's save and go back into Unity. Before we run the game, we have to set a speed on the ball. And it's alive. Of course, it goes through the wall because we decided that we are going to change the direction manually and we didn't do it yet. That was for the first method. Let's go back into the code for the second method. This time we will use the rigid body move position method. What is important to know is that in Unity the physics simulation runs at a different rate than the rest of the game. Mono behavior provides another method that is highly recommended for any physics update. And this method is called fixed update. Let's comment out the code in update, and after the method we type fixed and the editor should help you auto-complete it. We can remove the private for methods because it is private by default. Let's write this.rb.movePosition parentheses and inside rb.position plus direction times speed times. And this time, since we are in fixed update, we have to do speed times time.fixed delta time. Alright, save the script and try it out. It works the same way. The ball moves but ignores collisions. We have configured the ball to have a collider and it is set as trigger. Now we will check when the trigger touches another collider and change the direction of the ball. In the ball controller, we will type onTrigger and wait for the suggestions to appear. We have a few choices and the one we want is onTrigger enter. Whenever the ball starts touching another collider, this method will be called. And we will get the other collider as a parameter. This gives us a reference to the other collider. But we still need a way to differentiate between objects. One solution is to use tags. A tag is just a name that you stick on an object. Let's go back into Unity and select the player. In the inspector, you have a field called tag. I've already defined a tag for the racket. If you click on it, it shows all available tags. By default, game objects are untagged. At the bottom of the list, we can click on Add Tag and create new tags. There we simply click on the plus button to add a new tag. Let's call it wall. And we also create one called ball. Now select the player again and make sure it is tagged as racket. Then we tag the ball as ball. And finally, we select the top and bottom game objects and give them the wall tag. We can save and go back into the code. In our onTriggerEnter method, we will now need to read the tag and decide what to do based on that information. We can either read the tag directly or use a handy method called compareTag. If other.compareTag, and in parentheses we write the string wall, then we do something. If other.compareTag string racket, then we do another thing. Let's just think for 2 seconds here. The ball moves on the X and Z axis. When the ball hits the wall, we want to negate the Z value. This means we change the direction vector directly. Let's set direction.z equals to minus direction.z. When the ball hits a racket, we change the sign of X. So direction.x equals minus direction.x. Same code, just another axis. We can save and test it out. For the moment, the right side is empty because we have only one player. As a quick test, we can duplicate the player and position it on the other side. We will simply control both sides at the same time. Hit play and it works. The ball is a bit slow, so feel free to change the speed to your liking. Now it's still boring because the direction is always at 0.5. This makes the direction very predictable. We're going to change this and make it more dynamic. Alright, the ball's movement is way too simple. We are only changing the sign. There are not enough variations, and this makes the game boring. Let's upgrade the ball and make it change direction based on where it hits the racket. The player will then be able to choose more strategically where to hit the ball and hopefully surprise its opponent. We start by opening up the ball control script and remove the code inside of the second if statement. We don't need that anymore. First, we compute the new direction. It's a vector tree, let's call it new direction. And it will be equal to the position of the ball, so transform.position, minus the other.transform.position. Since we are going to use our speed variable, we want our direction vector to be normalized. We put all in parentheses and at the end, dot normalized. This will ensure that the new direction has a magnitude of 1. Right now with this code, we are going to have an issue. When the player hits the ball at the corner, it is possible that the ball gets reflected at an angle that is nearly vertical, and this is not good for the gameplay. The ball will take forever to arrive on the other side. That's for this. Then we can already say that the direction is equal to new direction. And now we will update the x and z values. New direction.x is equal to, and we actually need a variable to store the minimum direction we want. We don't hard code that number, we want to be able to tune it in Unity. Never hard code numbers. Public float min direction with a default value of 0.5. We want now to take the maximum value between the new direction.x and the min direction. Mathf contains all kinds of mathematical, functions. Now, new direction could be negative or positive. So let's take the absolute value. But then we lose the sign. Let's multiply by mathf.sign min direction.x. And we are good to go. I will copy paste this line and change x to z. Let's save the script and play. Great, the ball is now much more interesting and the direction changes based on where we hit it. Awesome. When we launch the game, the ball starts moving in the same direction every time. This is quite unfair to one player. We could program a rotation in the direction, or, and this is what we will do, add some randomness. In the ball controller, let's go to the end of the file just before the closing brace and write a new function. It's a private function that will return nothing, so void. And we call it choose direction. As a base, we can copy this line from the start method and paste it there. We want to randomize the sign in a way that it will multiply 0.5 by 1 or minus 1. Let's create a new float, sign x equals to math.sign, and inside we will use random.range to choose a random value between minus 1 and 1. We duplicate the line and rename sign x to sign z. Let's now just multiply the x value by sign x and the z value by sign z. Our method is ready, we just need to call it. In the start method, we can replace this line by our function. We can also say this.choose_direction, it works the same way. Don't forget to save and go back into Unity to try it out. Now, every time you start the game, the ball will choose a random direction. At this point, the player moves, the ball moves, but there is no one on the other side to play against. We copied the player just to test, but we will now make a real player too. If you have 2 green rackets, you can delete the second one. I've already prepared a second racket, which is essentially the same model, but with a different texture. It's a prefab, and it is located in the Cyberpunk 3D starter folder. Let's just drag and drop it into the scene and place it at the exact opposite. We can select player, copy the transform component, and then select the player 2 and choose paste component values. Now they overlap, but we will change the position x from -13 to +13. Then we also set the rotation to +90 degrees. For this game, we don't roll it too much and we simply copy each component from the player into player 2. We want the same rigid body and the same box collider. Click on the 3 dots next to the component you want to copy and choose copy component. On the other object, we choose paste component as new. We also copy the script And instead of the key W and S, we will choose arrow up and arrow down. That way we can have two humans play on the same keyboard against each other. Let's save and play. Alright, you can play against a friend, a sibling, parents, or anyone else. If the ball is too slow, just increase the speed. Remember to do that only when you are out of the play mode, otherwise the changes are not saved. Before we continue to implement, we must think about how we want our different scripts to work together. One thing is sure, it's very bad to try to put everything into one script. Don't do that. There's an important principle in software engineering, and it's called single responsibility principle. Each component in our game should be responsible only for its own functionalities. Here are some examples. The racket only handles itself and never other rackets. The ball manages its own change of direction. No other component should change the ball's behavior. And the goal decides for itself if a goal has been scored. But there is a problem. Sometimes you need teamwork between components. One component needs to say or ask something to another component. In Unity, we have several ways to make game objects and scripts talk to each other. For example, we can have direct references to another script. We can find a script in the scene. We can use events, and there are a few more. Each method has its pros and cons, so in this guide we will explore a few of them. Playing with or against another human is not always practical or possible. In those cases, we would like to play against the computer. For our game, we will upgrade the racket controller to be able to toggle between human and AI. This is going to be a simple Boolean switch. Our artificial intelligence will look at the ball and follow it based on the ball's position on the Z-axis. This means that the racket controller needs to know about the ball, and we're going to use tags to find the ball. Let's write some code. In racket controller, we add a new public bool called isPlayer. The default value will be true. Based on this value, we want to move the racket differently. We will keep the code well organized by copying everything that is in the update method and pasting it in a new method called moveByPlayer. Now in the update, if isPlayer is true, then we move by player. Else, we move by computer. This method does not exist yet, so let's create it. The player was moving based on the input. The AI can't do that. It will use the ball's position to decide. For that, we create a private transform called ball. And inside of the start method, we can use GameObject.findGameObject with tag and give the string ball. This must match the tag we defined. Also, make sure you use findGameObject with tag and not the plural version, findGameObjects with tag. We don't need the complete object, just the transform, so .transform. Next, inside the moveByComputer, we can compare the ball's position against our position on the Z-axis and do something. If it's bigger, then we move forward. If it's smaller, we move back. Otherwise, we don't move. The code is very similar to the player, only the logic to decide the movement changes. Let's save and we can uncheck isPlayer on the second racket, run the game, and we have our AI. A very simple AI, but still, it's a worthy opponent. I've added a final touch to improve the computer's behavior. I've added a float offset with a default value of 0.2 that I use to offset the center and make the AI react sooner to the ball's change of direction. Now it's also a good time to play a bit and tune the values to have the gameplay that you would like. You can make the AI slower or even unbeatable. You can tune the ball speed and overall find a good balance between the speed of the ball and the speed of the rackets. If you played a bit and scored a goal, you notice that the ball will disappear into the void of the scene. We have not yet defined the goal and what should happen when the ball enters the goal. The goal is an interesting component because we have two of them, one for each player. When the ball enters the goal of the left side, we give a point to the player on the right side of the field and vice versa for the goal on the right. A goal will have only one responsibility, and that is to detect the ball. The goal will have one script that will shout, "I detected the ball," and that's all it will do. In the arena, there is already two empty game objects called goal left and goal right. Let's add a box collider and edit the collider to make the goal nice and large. copy the box collider and paste it on the other goal as well. And that's all we need in terms of standard components. The goal will manage itself and detect if a ball has entered. For that, we create a new script and call it goal controller. This script will not need much because it acts as a kind of a sensor. We can remove both start and update. We can even remove some of the unused imports. And we add on trigger enter. We use on trigger because we know that the ball is a trigger. Using compare tag, we check if the other collider is the ball. If yes, we print something in the console. Save, and in Unity we have to add the script on both goals. Select goal left and goal right and drag the script in the inspector. Hit play, and whenever the ball goes into a goal, we see our message in the console. Alright, but this is not enough. We have to ask ourselves two questions. Who will react to the goal? How does the goal communicate that the goal has been scored? The goal acts as a sensor. We need a referee that will take the final decision. We need a unique game controller. And to communicate, we are going to use Unity's built-in event system. Let's first take care of the game controller. Even though we try that each component has its own responsibilities, at some point we need a central place that will manage the complete game. In our case, we need a component that will keep track of the score, start the game, and reset the game. We will create a new C# script called game controller. In the hierarchy, we will create a new empty game object, and we will also call it game controller. Our game controller will live in the scene, but not physically interact with anything. It's just there. We can place it at the origin. And in the inspector, we can also give it a colorful label so we know it's there. Then we put our script on it, and we are ready to write some code. Let's open up the game controller script. We will now implement some basic code to track the score of each side. Let's create two variables to track the score of the left side of the field and of the right side. Both will be private integers, so int, and both will start at 0. Now we need to provide the goal a way to talk to the game controller. For that we'll make two public methods called scoreGoalLeft and scoreGoalRight. When the goal detects the ball, then goal controller of the left goal will tell the game controller scoreGoalLeft, and the goal controller on the right goal will call scoreGoalRight. Inside each method, we increase the score variable by 1. We write scoreRight plus equals 1. We could also write scoreRight equals scoreRight plus 1. It's the same. Other one is shorter. Just make sure that scoreGoalLeft increases the right score and vice versa. That's all for the game controller for the moment. Now we can finalize the goal controller, which will be able to call scoreGoalLeft or right because they are public methods. And public methods, as the name indicates, are public and accessible to outsiders as well. This part is pretty cool. We are going to create a Unity event, and this will allow us to make the goal notify the game controller that the goal has been scored. Let's open up the goal controller and implement some little magic. It's not magic, but since this course is super beginner friendly, we will not cover exactly how event works. We will just use them. First, we need to import a new module. At the top, we write using Unity engine.events. Then we can define a new public Unity event and call it onTriggerEnter with a lowercase o. We call it like that because it's very explicit. Now here comes the special part. Instead of printing, we will write onTriggerEnter.invoke with parentheses. And this will invoke the event and something will happen. But what will happen? We will not define it in the code. We will define it in Unity. Save, and let's go back in Unity. Select one of the goals, and there it is. A new field appeared. And this is a list of events that can be defined. Right now, there are no events. So we click on the plus button, and where it is written none, we will drag and drop the game controller game object. And where it says no function, we will select game controller, score goal left, because I'm on the left goal. That's it. When the goal detects the ball, it will invoke the event. We didn't define in code what will happen. We do it in Unity. This is really awesome because we can have one clean goal controller and use it multiple times by configuring in it differently on different game objects. Let's not forget to do the same on the right goal. Click on the plus, drag in the game controller, and choose score goal right. Save and launch the game. If all is correct, you should see the message score goal left or right, which is the message that we print in the game controller. This means that our communication between the goal and the game controller worked. What's the point of having a score if you don't show it on screen? The game controller tracks the score of each player, but that value is hidden in the script because it is private. And we want to keep it that way, but we also want to display it. We need a UI, a user interface. A UI is very simple. It's a 2D space that overlays on the camera view. Let's see how it works. In our hierarchy, our favorite place to create new objects, right-click and choose UI and then Panel. You will see something has changed in the scene. There is a huge panel that just appeared. Even though it looks wrong, it is perfectly correct. In Unity, UI elements are put on a canvas that will be overlaid on the camera. To see the full user interface, we can click on the 2D button on the Scene tab. Now we are in 2D mode. When we created the panel, Unity automatically created a canvas and an event system object. Now select the canvas and put your mouse cursor on the scene. Now hit the key F for frame and it will frame the object into view. Great, this is our complete UI. It's not impressive, but we will get there. We want that the panel is just at the top of the screen. We could drag the corners and resize it, but that is not very precise and might not work if your screen size changes. We need a way to make sure that the panel correctly stretches to any screen size. To do that, we can click on this box in the inspector. It allows us to change the pivot, position, and stretch settings. Now hold Shift and Alt or Option on Mac and choose the option Top Stretch. After that, we will change the height to something like 220. For me, this value looks good. I hope you agree that the panel is very ugly. It's a default look for every panel and luckily we can remove or deactivate it. However, it is useful for visualizing the UI while you set it up, especially by choosing different colors. Alright, let's add some text. It's a UI element as well. So right click on the panel in the hierarchy and then UI text. Now we have a little text box. We will not worry about the position and size because we will do something after that will take care of it automatically. For now we will type in the text 0. We set the font style to bold, the font size to 100. We choose align center horizontally and vertically. And finally we set the color to white. Alright, I'll just rename this to score left, copy and paste it and rename the second one to score right. Okay, now we will select the panel and add a component that will take care of the layout for us. The component is under layout and is called horizontal layout group. For this game, we will set child alignment to middle center. Then we will uncheck child force expand for the width. And we will let this panel control the height of the text elements. And there you go. If you resize the panel, the text will adapt automatically. We are now all set for the coding part. We have a UI, but it's doing nothing. We have to hook it up to some code so that it will update when the score changes. For this game, we will keep things very simple and we will implement the UI update inside of the game controller. We need two variables to know what are the UI text elements. Let's write public text score text left. And we have an error. The type text could not be found. That's because we have to import the UI module first. At the top of the game controller script, we write using unityengine.ui. Now it's working. We duplicate the line because we also need score text right. Next up, when do we want to update the scores? After a goal has been scored. I'll call a method called updateUI. This method does not exist yet, so let's create it. It's very simple. We will take the score text left .text and set the value to score left. And since this is a number, but we want a string, we will do toString with parentheses. Alright, save the script and go back to Unity. We have added two public variables, which means that we need to put something in there. Drag the UI text element score left from the hierarchy into the score text left field. And again for score text right. Save and play the game. If all is correct, you should see that the score is being updated every time there is a goal. It's that simple. Right now, as soon as we start the game, the ball moves. It's a bit fast and we would like to implement that the player has to hit the spacebar to start the game in the first place. We're going to implement this feature in the game controller. First, we need a variable to keep track of the fact that the game starts for the first time. This means private bool started equals false. In the beginning, the game is not started. Then every frame, so in the update method, we first check if this started is true. If yes, we return. This will exit the update method and the rest of the code will not be executed anymore. So if the game did not start yet, we can continuously check for the player input. If parenthesis input.getKey, keycode.space, curly braces, and then here we set started to true and we start the game. I'll put a comment there because we are kind of stuck. What does it mean to start the game? Here it means that the ball starts moving. And now we're in a situation where we need to communicate with another script again. The game controller should either tell the ball what to do or control it directly. And actually, we will explore a mix of both techniques. Still, the ball moves automatically when the game starts. In a way, it makes sense since the ball is responsible for itself. However, here our game controller must act as a referee and decide when the ball is allowed to move. We will do the following changes in our code. First, we will add the method stop and go on the ball controller. Then we will make sure that the game controller knows about the ball, and the game controller will be able to say go to the ball, but only when the player hits the spacebar. Let's start with the ball controller script. We add a new private bool stopped and set it to true. In the fixed update, we check if stopped is true and return if it's the case. This will make the ball not move anymore while the variable stopped is true. Alright, the game controller will make the stopped variable change, but not directly. We will provide some public methods to facilitate it. Public void stop. Inside, we change stop to true. And public void go, where we set stopped to false. In the go method, we can also call choose direction. That way, the ball will choose a new direction every time it starts and later restarts. We can even remove choose direction from the start method. Alright, now our ball controller is complete. We can go ahead and finalize the game controller. We just finished the ball controller. We can now complete our cross-script communication in the game controller. The first thing we need in the game controller is a reference to the ball. So public game object ball. To call methods on the ball controller, we are going to also need a reference to the script. This time, private ball controller ball controller. Okay, we will link the game object in Unity and get the script here. In the start method, we write this.ballController equals to this.ball.getComponent ballController. Let's not forget the parentheses and semicolon. Before, we have called getComponent in ourselves. This time we call it on another game object. We can save the script and go back to Unity. Let's select the game controller and there we need a reference to the ball. Here it's very important to drag and drop the ball from the hierarchy and not from anywhere else. It must be the ball game object that is in the scene. Great, and we just have one line of code to add. In the game controller update method, now that we have the ball reference that allows us to get the reference to the ball controller, we can call this.ballController.go in the if statement. Save, and there is only one way to find out if it works. Click on play, and the ball does not move. Hit space, and there it goes. Awesome. Next up, we will reset the ball whenever there is a goal. When a goal is scored, we want to reset the ball to the center of the arena and start again. We did most of the work already. Resetting the ball is very easy. But we will need to remember the starting position of the ball. Who says remember says variable. In the game controller, let's add a private vector tree called starting position. We are only interested in the XYZ position. Now, in the start method, we write this.startingPosition equals to this.ball.transform.position. After that, we will create a handy method for resetting. Private void reset ball, curly braces, and then first we stop the ball. So this.ballController.stop. Then we change the ball's transform position to this starting position. And finally, we call go on the ball controller. We will reset the ball after every goal, so we can call reset ball in score goal left and score goal right. Save and run the game. The first time we hit spacebar for starting the game, and then after every goal, the game resets automatically. Awesome. At the moment, the ball is instantly launched when we hit the spacebar and instantly resets and goes flying again. That's not ideal. It would feel much better to have a small countdown to let the player prepare. We want to show a 3, 2, 1 and start on the screen and only let the ball move at start. For this game, I've prepared the countdown for you. It's simply 4 text elements that are animated. In Unity, go into the Cyberpunk starter folder and drag and drop the start countdown prefab. It's one of the blue icons, and drop it into the canvas. Let's now create a new C# script called starter and place it on the start countdown object. Now open the script and let's think what we need. This script will only be responsible to control the animation and to tell the game controller, hey, this countdown has stopped, it's time to start the game. This means we need 2 variables: the game controller in our scene and the animator that is on the start countdown itself, both private. In the start method, we can get the game controller by using find object of type, and within the comparison sign we say game controller. Next line, this.animator equals getComponentAnimator. After that, we will write 2 public methods. Public void start countdown. This will be called by the game controller. Inside, we can use the animator to start an animation. This.animator.setTrigger and in quotes, start countdown. Again, in this course, we keep it simple. I will cover animators in detail in another course. And the second public method is start game. And inside, we're going to relay the same onto the game controller. So this.gameController.startGame. You might have guessed that the method startGame does not exist on the game controller. So let's go ahead and implement it. In the script game controller, we can write public void start game, and inside simply this.ballController.go. When we start the game, we just give the green light to the ball. Alright, now that the countdown is set up, we have to find the right timing to start the game based on the animation. Now we are going to finalize the animation. What we want is that when the start text appears, the game starts at that exact moment. To do this, we are going to use animation events. First, at the top, go into Window, then Animation, and then again Animation. A new panel will open and you can click on the animation label and drag that window anywhere you like. I find that putting it next to the console at the bottom is the most comfortable. Now when you select a game object that has an animator on it, like the start countdown, you will see the animation clip that is on it. Click on the animation play button and it will preview the animation in the scene. Alright, stop again by clicking on the same button, and in the timeline you can click and drag the animation head. Let's now find a good time when we want the ball to start moving. Let's say around 4 seconds at frame 240. Let's create a new animation event at this place. So with the head at frame 240, click on the last button right under it. It looks like a pen with a plus. It will add an event. Okay, and a small icon has been added where our head is. It is a blue because it's selected. When you select it, you see that the inspector changes and there's a field called function. Click on the drop down where it says no function selected, and there we see the public methods available on this object. In this case, it's a starter script because it's on the start countdown object right beside the animator. Let's choose start game. Now, when the countdown starts at second 4 or frame 240, this event will be called on our script. Let's just take a look in the starter script. We see that we will call start game on the game object, and start game on the game object will launch the ball. Seems all good. There's only one small detail that is missing. Someone needs to call start countdown, and that someone will be our almighty game controller. Here we go, it's the moment where the last pieces of the puzzle all come together. Our ball controller is done and does not decide anymore when it can move. The game controller decides. The starter script, which basically is like the guy shooting the gun at the 100-meter race, gives the actual start signal. What is missing is the game controller letting the starter script know, hey, please start the countdown. Inside the game controller, we add a public starter. This will hold the reference to the countdown script. And then in the update, we need to change one line. Remove the ball controller go, and instead we say this.starter.start countdown. The same in reset ball. Replace ball controller go with starter.start countdown. I just changed the order of the public variable to have the same order as in the guide. Okay, save, and in Unity we just need the reference to the starter script. We know it's on the start countdown object. So with the game controller selected, drag and drop the start countdown object from the hierarchy into the starter field. Unity knows which component to take. Save, hit play, and let's try it out. Space and the countdown starts. And when there's a goal, the ball resets and the countdown starts again. Awesome. We basically finished the core gameplay. Now it's time to polish the game a little bit more. What I would like to show you is how to place some particles and later how to spawn particles as well. In the Cyberpunk starter folder, there are 2 particle effects ready to use. We're going to use the smoke VFX first. If you double click on it, it opens the prefab in isolation. And you can see how it looks like. To exit this mode, click on the small arrow. What we will be doing is simple. We will place a smoke VFX in the player object and let it play forever to simulate a kind of exhaust. You know, because cyberpunk, pollution and stuff. So let's select the player and hit the F key to frame it into view. Open up the object in the hierarchy and then we simply drag and drop smoke VFX onto the player and just under the object called racket. Now, use the move handle to place the smoke particle effect in the middle of the engine. When you are happy with one, duplicate it with Ctrl or Command D and place it on the other side as well. Alright, looks good to me. Let's just repeat this process for player 2. Make sure the smoke VFX objects are children of player 2. Usually we would work with prefab variants and we would only have to do this step once. But for this beginner tutorial, we keep it very simple and explore Unity so that we can also see those limitations and later understand why Unity provides more advanced systems and tools. And that's all for this. It's a subtle effect, but it's by adding small effects together that you can make an awesome looking game. It's easy to overdo it, so take your time with VFX. Next on our list of extra details is sparks. Our arena is pretty massive, the rackets are heavy and mechanic looking, the ball looks really strong, but when 2 objects collide with each other, it's looking pretty dull. We need some sparks whenever 2 objects touch each other. Let's do it. In Cyberpunk starter folder, there is a spark object. If you double click on it, you will see that it's a simple one-shot particle effect. It plays once and that's it. You can click the play button to see it again. Alright. We're going to spawn or create those particles when the ball hits the racket or the wall. This means that we will put the ball in charge of this effect. Let's open the ball controller and we're going to need to know what kind of VFX we want to create. Let's create public game object sparks VFX. Prefabs, the files with the blue icon in the project folder, are basically templates to create a new object instance. So in this case, we're going to create a new object in our scene by code. In the onTrigger event method, we will add some code. At the top, we create a bool hit that is false. Inside each if statement, we will set hit to true. That way, we know if something has been hit. And at the end of the method, we check if something has been hit. Then we show some sparks. Creating a new object in Unity by code is called instantiate. So we write instantiate, parentheses. What do we want to instantiate? Our sparks VFX game object. Where? Well, where the ball is. So, comma, transform.position and comma, transform.rotation. This is already enough to create the sparks, but our particle effects shoot sparks once and that's it. We don't want to keep this object around, because it just takes memory in our game and it will slow down over time. Let's store the result of instantiate in a variable of type GameObject called sparks. We will call another function right after. Destroy, parentheses, sparks, comma, 4f. This will schedule to destroy the sparks object after 4 seconds, and that should be enough time. Save and go back to Unity. Select the ball and drag the sparks prefab from the project folder into the sparks VFX field on the ball controller. Let's try it out, and there you go, fancy sparks. In the hierarchy you see that new objects are being created and they get destroyed after 4 seconds. Very cool. A game is pretty boring without sound and music. Let's fix this. First, we should probably create a new folder in art and call it music. Within the zip file that you have received with this course, there is a folder called music with an MP3 inside. Just drag and drop it into the project panel. If you select it, you will get some information in the inspector. You can also play it there. In Unity, to play a sound, you need an audio source. It's like a speaker. By default, on the main camera, there is a component called audio listener. Those are like the ears of the player. Our game is quite simple, so we could place the music right on the camera. Let's add a new component called audio source. There are many options, but we are only interested in a few of them. First, we drag the MP3 file into the audio clip field. Play on awake is checked, which means the sound will start playing automatically, and we want the music to loop when it is done. I will also reduce the volume from 100% to around 70%. That's it, now you have cool music in your game. Congratulations, you just completed Cyberpunk 3D. I hope you had fun creating it. Let me know in the comments below how it went, and if you want to have more tutorials like that about other games, feel free to let me know as well. With that being said, make sure you like this video and subscribe if you want to learn more game development. I thank you very much for watching this video. Keep it up and see you next time.